Section 10.1.41. According to a survey, 67% of murders committed last year were cleared by arrest or exceptional means. 50 murders committed last year are randomly selected, and the number cleared by arrest or exceptional means is recorded. For part A, it says find the probability that exactly 42 of the murders were cleared. Okay, so what we're going to do is we're going to use the binomial probability distribution function to compute the probability. Okay, so recall that the binomial probability distribution function states that the probability of obtaining X successes in n independent trials of a binomial experiment is given by this formula. So the first thing we need to do is we need to find P. So in order to find P, okay, we know that we have 67% of the murders. So that's 67% over 100%. So that gives us a value of 0.67. Now also notice that the number of independent trials for this situation is the number of murders committed last year that are randomly selected, and that's 50. So therefore, we're going to say that n is equal to 50. Okay, now we want to be able to find the probability that exactly 42 of the murders were cleared. So that means we're looking for P of when X is equal to 42. So we're going to plug that into our formula. Okay, so we have the following. We know that n represents 50. So we have 50 and then a combination, and then X represents 42. We know that we're going to multiply that by P, which is 0.67 raised to the power of 42 times 1 minus P, which is 1 minus 0.67 to the power of n minus X, which is 50 minus 42. Okay, so we can either use our calculator or we can actually do this by hand. Well, let's go ahead and use our calculator. So using our calculator, we want to find the combination. So we're going to put in 50, and then we're going to go to math and then scroll over to the right to probability and go down to number 3. And then we're going to put the value of X, which is 42, and then we're going to hit enter. And there's that number that we get here. And then we're going to multiply that number by the following. We're going to multiply it by parentheses 0.67 to the power of 42, and then select enter. And then we're going to take this number and then we're going to multiply it by 1 minus 0.67. We're going to raise that to the power of 50 minus 42, which is 8, and then select enter. And then therefore, we're going to get the following result. So we're going to round that to 4 decimal places. So rounding that to 4 decimal places is going to give us approximately 0.0037. So therefore, the probability that exactly 42 of the murders were cleared is 0.0037. Okay, now let's say if we wanted to use just the TI-84 prompt calculator. Okay, so what we would need to do is we would use the Binomial Pdf, because the Binomial Pdf function, let's go ahead and pull that up here. We go to second distribution here, and then we're going to scroll all the way down to where you see Binomial Pdf, which is A. We're going to hit enter. Okay, so binomial PDF, okay, that P means when we're dealing with an exact number. Okay, so we know that the number of trials is 50. So that means that this number is going to be 50 written first. Okay, and then the value of P is the proportion, which is 0.67. So we're going to put in 0.67. And then we're going to put in, what is the X value? Well, the X value is going to be 42. Okay, so once we do that, we're going to select paste. And then we're going to hit enter. And then when you hit enter, you're going to see the same value. So that's going to give us 0.0037. Okay, if you want to use Statcrunch, okay, let's pull that up here. So here we have Statcrunch. Okay, so what we want to do is we want to go to Stat Calculators, and we're going to go to Binomial. Okay, we know that the number n is going to be 50. We know that our proportion is 0.67, and we have an exact. So if it's exact, that means we have an equal sign, and we're going to put in the X value to be 42. And therefore, you can see that it computes that result, which also gives us 0.0037. Okay, so this is by hand. Here's your TI-84, and there's your Statcrunch. All right, now let's go to the next one here. It says find the probability that between 37 and 39 of the murders inclusive were cleared. Okay, so what we're looking for here is the following. We're trying to find the probability, okay, the value of X is going to be in between 37 and 39. Okay, so what we can do is we can create individually, okay, 3 versions of this if we did this by hand. That means you're going to have to find the probability of 37 plus the probability of 38 plus the probability of 39. Okay, and so what you would have is the following. You would have the following formulas. You're going to have the combination where you have 50 and then X is 37 with 0.67 raised to the 37 times 1 minus 0.67 to the power of 50 minus 37, and then that would be plus. Then you do another combination of 50, and now that's going to be 38 times 0.67 to the 38th power times 1 minus 0.67 to the 50 minus 38, and then that would be plus, again, the combination 50 with 39 times 0.67 to the 39th power times 1 minus 0.67 to the power of 50 minus 39. Okay, now if you put that all in your calculator and you add that all up, well, that's going to give you approximately 0.1527. Okay, now if we want to do this on the calculator, so what we want is we want a probability that goes all the way from 37 to 39. Okay, but our calculator, what it does is it'll add up everything up to 39. So we have to subtract everything that's 37 and below because it's including 37 and it's including 39. So what that means is we're going to have to use the cumulative. So we're going to use the Binomial Cdf, okay, where we have 50 trials, okay, and we know that our X value proportion, represents 0.67, and then our x value is going to be 39. But what we need to do is we're going to have to subtract everything all the way up until 36 because we want to include 37. So we want to subtract the binomial CDF starting at 50 trials, a proportion of 0.67, and then everything up until 36. Okay? Because if you do that, then that's going to allow you to be able to then find out everything in between 37 and 39. So let's go ahead and calculate this on our calculator. So we're going to go ahead, second distribution. We're going to go to Binomial Cdf. We got 50, we got 0.67, and then we're going to put in 39 and then paste. So that means that what this has done is it's adding everything from 1 all the way to 39. But we want to subtract everything up from 1 to 36. So we're going to hit subtract, and then we're going to go to second distribution again. And then we're going to go to Binomial Cdf. And this time again, we still have 50 trials. We still have the proportion of being 0.67. But now this number's got to change to 36. And then we're going to select paste. Okay, and then we select enter. When we select enter, you should see that we get the same result that we got here when we just added those three up. We get 0.1526. Okay, now if I want to use Statcrunch, let's go ahead and do that here. We want to make sure it's in between these two values. So when you select between, what numbers do we want it to be in between? Well, we know n is 50, we know the proportion is 67, and we want this to be in between 37 and 39. And therefore, you see that we get the same result using Statcrunch that we did the other two results. Okay, so there are three options that you can choose for that. Okay, next, let's go to part C. So part C says, would it be unusual if fewer than 16 of the murders were cleared? Why or why not? Well, first and foremost, okay, we need to check that first that the value of n times p times 1 minus p is going to be greater than or equal to 10. Then the probability distribution will be approximately bell-shaped, and the empirical rule can be used to identify the unusual observations. The empirical rule states that if the observation is less than the mean minus 2 times the standard deviation or greater than the mean plus 2 times the standard deviation, then the result would be unusual. So first, let's find n times p. Well, we know that n is 50. We know that p is 0.67. Multiply that by 1 minus 0.67. We want to make sure that it's greater than or equal to 10. Well, the number that we get on the left side is 11.055, and it is greater than 10, so therefore that checks. Now we want to apply the empirical rule. Okay, so in order to apply the empirical rule, to determine whether it's unusual or usual, if fewer than 16 of the murders were cleared. To do so, we need to calculate the mean and the standard deviation. So we want to find the mean. So the mean is going to equal n times p. We know the value of n is 50. The value of p is 0.67. So therefore, the mean is going to be 33.5. Okay, number 3, we want to find the standard deviation. And the standard deviation formula is equal to the square root of n times p times 1 minus p. So that means we have 50 times 0.67 times 1 minus 0.67. And taking the square root of that gives us approximately, to 4 decimal places, 3.3249. Okay, so now what we want to do is we want to calculate the following. We want to find out what is the mean minus 2 times the standard deviation, and then the mean plus 2 times the standard deviation. So what we're going to do is we take 33.5 minus 2 times 3.3249, and we get the value of that to be 26.8502. And over here we get 33.5 plus 2 times 3.3249. And so therefore that value gives us 40.1498. So going back to the question, would it be unusual if fewer than 16 of the murders were cleared? Why or why not? Well, 16 does not fall within 26.802 to 40.1498. So then we can say that the following. Notice that 16 is less than 26.8502. So according to the empirical rule, any value less than 26.8502 or greater than 40.1498 is unusual. Therefore, it would be unusual if fewer than 16 of the murders were cleared.